好吧，那个 again 哈，那不是说非常顺畅。Alright, never mind. Probably just a few students can connect it. So if your computer is not connected, please take a look at this video. Alright, so let us go back to what we have. Okay, this is the message of the simplest way. So sometimes actually we really want to interact with the user. So this invocation is not usually we should specify the buttons. So message box button is an enumeration. So what you need to do is just select it. So type a blank space and then M S B. Oops, nothing came out right. M. See, once I type M, Internet has highlighted this enumeration, message box buttons, dot. All right, they are all kind of combination. Just one button, okay, or two buttons, yes, no, cancel. So remember that the message box is a standard message box. Used in Windows system. So if your application needs to interact with the user, the simplest way we just ask the help from this message box. So what I'm going to do is select yes, no, and then we like to add some graphics hint. So again, you can special icon, okay, message box icon, and icon just Windows system just has 4 different kind of icon, just 4. So again, NBI, see message box icon dot. Remember that I just said there are just four kind of icon will appear on the message box. But if you look at the selection, well, probably more than 4, right? But probably more than one the same. So for example, if I put an L, E-R-O-R, L is the same as the hand. There's a hand. They are the same. So if I specify the icons, it's L there. Right? Take a look at this function explanation. After the message box show, the user's selection will be sent back to you as this type, dialog result. So dialog result is another enumeration. So you will know what the user selected after the message box show up. Okay, so specify the type, dialog result, answer. Right? This is the usual way we interact with the user via the message box. Message box, are you a higher question? Yes, no, L. Then we will check if answer equal dialog result, right? Enumeration dot yes. And we do something. Okay, this is the user's way. We use the message box. We interact with it. All right, I don't want to implement the other property. I just let you know. The message box. You should study a little bit about the usage of the message box. So text, caption, icon, buttons. So user might click on no, yes, right? No. In fact, excuse me, I did not put a break. So if I set a breakpoint there. So feel free to use the message box, but don't just pop up a message and tell user, no, you are wrong. You should not do that. Okay. So usually we use message box is try to get interaction with the user to get the user's decision and then make a different kind of logic execution. So if I click on yes, so your answer, you see, answer get back yes equal dialog result yes. So this is the cases we use the message box to help us proceed our logic according to the user's selection. Okay. Now this is the one because some student has been using that. All right. So, is there any question about this message box? So you can feel free to try to specify different kind of solution to see what we have. For example, if you select another icon information, the icon will be a little bit different from previous one. This is information. All right, so it is standardized. Message box has been standardized. You need to know this kind of mechanism. You need to select the correct one. So this time I click on, use a click on no, right? So how about the answer? Answer is no, right now. Okay. Okay, since right now we have been using a lot of object-oriented technology to implement our fuzzy inference system. Probably this is the first project you work on the inheritance. So we need to go back a little bit, go back to the class hierarchy in order to learn this kind of mechanism, because some students might be confused. When should we specialize virtual function, and when should we override it, right? And when should we inherit from a parent class? So I mean, you can follow me. I mean, try it. Once you type it, you can get the feeling about this object-oriented stuff. Okay. So let us go back to where. I mean, you open your project, and then you can follow the example that I'm going to show you, and you can type it, and then you can learn it by yourselves. So let us go back to the program.cs. The main function is the entry, right? It's the entry or a C# application. So we can study a little bit about object-oriented skill right here. I mean, before we enter our user interface. Does not harm at all. Okay, so let me just delete it once you have done everything. So let us go back to the program.cs. So suppose right now, outside, you see, pay attention to the location you type the code. So this is the class definition. Visual Studio prepared this class for us, right? And C# program usually always start from the main function, and the main function have a lot of restriction. This function must be static, must be a member function of a class. So we kind of wrap a class, and then this function should be static, and you can return nothing or return int, and you can take. I think the only argument can take is array or string. Is a string array. Okay, fine. Never about that. So outside this class definition, let us quickly just define our class. Suppose right now I have a class X, right? So we define a class, and probably we have defined there is a data int a. Fine. So it's very simple. You define a class X class, and after that we define another class. Probably I have added a function. Okay, so I have a function public, and this time I kind of fulfilled the accessibility issue. I let this data set to, so I can put the initial value there. And publicly I can call a function void, return nothing. I can call it f function. And I think, what should I do? Do I have a console? I don't know. Let me try it. Let me try it. Console, right line. So I have a class specified up to this point. X class, the class has one data, right? A is int. This class has a public function f, right? So let us just use it in the first line of our main function. Try to get some feeling about object instantiation. So I create an x. I have an x. Excuse me. I have a variable x, lowercase x. We need to neuter it. It's a kind of different. I mean, from C++. Once you define a class in C++ programming, some of you might have experience in C++, right? So C++ is similarly, you define a class, then sometimes you will say, well, okay, right now I have an X object right here. Once main function is given, I have an object X, lowercase x, ready for us to use. And for C#, we have this kind of data type, right? pointer. And also we have this kind of reference. It's really confusing. I mean for the user. So if you are not good at the C++ or C, that is because you did not get understand about so-called address and the pointer stuff. For now, for Java and for C# programming, we kind of fulfill that. You don't worry about that. We don't have a pointer type. We don't have a reference type. What we have X right now is intrinsically a pointer corresponding to the C++ programming. So remember that in C# programming, every object variable is actually reference. We call it a reference type. So it is not. So we need to know it in order to have this data instantiated in the heap memory. Okay, so we use a new X, right? Since we did not provide any constructor function or the X, so it's very simple. By default, because you will say that, okay, since your class does not provide any constructor, so definitely user can use a default constructor in order to create an object or an X for you. So right now is X. So then we kind of X invoke function, right? Everything is good, right? So okay, so up to this point. So let me show whether can I pop up console windows or not. I don't know. So about to execute it. Do I have console? No, unfortunately, right? No, I cannot pop up console. So I may not know what's going on here. Okay, it's pity. All right. So I'm not going to have it, but so what should I do? Okay, never mind. Maybe let's go back. Okay, forget about that. So right now I have X class ready for us to use. So let me go back to our main phone again, because we need to use the bracket. So again, we add a button back. Within this button, dynamically add a X equal new X, right? And then probably our return string. So I simply return just tell you that a function has been called. X is belong to capital X. Yes. So you will get once this function is called, you will get a string. So let us go back to here and then do I have a status bar now? Okay, now I quickly add a button here, add a label. Not label. Label is not good at all. Okay, this environment is not good for us. So, okay, probably let me forget about this structure. So can we quickly, well, probably this is the time we add another project to our solution. So remember that we have a solution, wrap up our project, right? So click on this solution, right click at it, try to add a new project. Okay, we add a new project. And we just want, what we want is just a console project. We are not going to involve any user interface. So make sure you select C# Windows, not library. What we want to add is a console. The channel is called 主控台, console again. But make sure, not this one, not .NET Core. We add a project. We try to add a project to learn the object-oriented technology a little bit. I will going to show you how to do that there. So we have a C# Windows console project ready. So by default, it's called console application 1. Fine. And where is the location? The location, since you add a project to your solution, so all the source code has been wrapped up as a subfolder within your solution folder. So it's okay. It's okay. Don't worry about it. You don't need to special anything. just build up it. So we kind of add a console project to our solution in order to learn a little bit about the object-oriented technology right here. Okay, so right now you have two projects, right? You have two projects. So if you take a close look, only one project is highlighted in bold face. So that means once this button is clicked, this project will be active one. But right now we try to learn something, right? So please click on this project and then right-click on the button. Select this command. Set this project as the startup project. Set this as startup project. So you will see, well, the name of this project is in boldface, right? Boldface. So that means once this button is clicked, this project will be compiled and executed in debug mode. So let us click on it. All right, this is console. Console is just the command prompt. So nothing happened, right? But actually, something to happen. The application has been executed and then gone in the terminal right here. Because you see, take a look at this project. Only one C# file is prepared by the Visual Studio for program.cs. Right? It looks the same, right? Look the same. So the only interface we can interact with the user is the console. So console is the most important thing. So you put a console, read the line. There's a function call. Then the screen will hold there. So once we start this project again, the console will remain here. You see the cursor is blinking right here, right there. Try to accept any input from the user. So if I type anything, or even I just hit return, it will receive the whole line. So the console receives the line, but nothing will be executed, right? So it's end. So end up with this program. Okay, so let us bring back the code that we have been done in program.cs for this project, right? So let me copy it. And let me just cut it. Fine. Cut it back to this program.cs. So right now in our console project, I have two classes specified, right? Program is prepared by the Visual Studio. X is designed by me. But this time it's very simple. I just ask the console write line. Write this text out. Void. So we have a class X. X has a data A and have function F. So within the main function, we kind of instantiate X object, right? So we need to new it by invoking the default constructor. So right now I have an X object ready. So I can X dot call F function, right? So that is the way we want to have. All right, so let us see what will happen. I can remove this breakpoint. So up to this point, right? Up to this point, x.f is called, right? So we know x.f called. Okay. So what is that? So later on, we might inherit from the x class. I call it xd. Inherit from x. So after this, the definition, I have another data, maybe 22. And I have another function, void, g function, console, write line. So here, xd, right? G function call. And probably I might add something. Okay, I put a string there. So I add a placeholder to print out a value. So I call it a equal. So let you know the memory of a did allocated by the computer. B equal B. So add that formatted string. So we have AG, right? And how about A? How about A? Because you inherit it from A, right? So below now I can add A equal what? And remember that because it's probably is not good for the well, later on we like to change it into the protected, right? But right now, since our program is another class 1 to SSS, so we are not SS. It's okay. So usually we will say protected. That is what we have learned, right? So we start from protected and data is public. So in this way, so this is just show you that XD do contain data B and A. So we would like to print it out. Okay, so let us go back to here. So we have X, right? We have XD object. Lowercase XD equal new XD, right? And then we invoke a G function. All right. So let's see what will happen. So X object just have data A, right? How about XD object? XD right now we have A and B ready. The derived class do contain the data inherit from the parent. Okay, if it is, you see, if it is private, excuse me, if it is private, I mean, especially in the parent class, you will see error came out. See, you see, red career came out. You cannot access, even though I have data A, but I cannot directly access in my function. That is the reason you need to put it specialized protected to share within this class family. Okay, so the idea is that we can keep have a class XDD inherit from XDD, right? And we call it H function, right? So it's XDD H function. And now A, B, and then C equal C. Excuse me, made a mistake. XDD inherit from D. So everything is okay. Okay, so right now we have a family of X classes, right? But the interesting thing is that why we want to design such kind of structure. That is because if an object or the derived class, we can always treat that as the parent class. Okay, so take a look at it here. So let me finish this one. XDD, right? New XDD. And then XDD or G function. So everything should be fine by there. But can I just because what we want to set up a family, because we always usually treat the object XD as a reference or a parent class. You see, call it XDIEF. Can I assign that XD? Take a look at this here. XD is an object of XD class, right? But can I assign myself to the parent reference? That is the way we would like to specify that. All right, so that should be okay. And how about XDDIEF? XDD. That is the way I'm saying that if you are a children of the derived class, can be regarded as a reference or parent class. Why we want to do that? Because later on we know once we finish a class family design, we don't know when or where a user might want to inherit from this class. So we don't know in particular what kind of derived object will be created. but they should have similar behaviors as the one in the targeted class. So XD can be assigned to the reference. So start from the XD reference. What we can access is that the parent function only. Even though the object, the reference is actually the derived children, it can always access the top labels function. Why we want to do that? Okay, later on you will see why. So here today you need to learn another operator. The operator is called as. Another operator, lowercase a, excuse me. Another operator is called as. As is cast. So please, if you are not familiar with these two operators, Google it. So let us take a look. Take a look at this expression. Bool x, let me be equal is its expression is that is a binary operator. You need to specify the object in the left hand side. So XD is X. We'd like to know what XD is X. Bool B1 XDD is X. And we also want to know Bool B2 X is XD. You see, X is the object of the top class, right? X is X. Can I treat the X object as a derived class? So you need to know this kind of B3 X is XDD. So sometimes we need to figure out, is this object derived from the parent? If that is true, then you will get true right here. XD is X. The answer is true. So later on we will see it. So let us go back to the setup breakpoint to see the differences between these objects. So up to this point, right, we have XDD there, so we type everything. After each function is called. You see, so XDD object is the, if we say that it's a father, son, grandson, right? So grandson is actually larger than the father, than the son, and then the father. This is the father just have data A, right? And the son has another data B, and grandson had another additional data C. So actually, the grandson is powerful or bigger than the parent. So always remember that. So then we step into this statement. Can I regard it, even though XD is a derived class object, right? Can we treat that as the parent class? So if I execute it, it's okay, right? So right now, XD is what? It's an XD object, right? How about the XD reference? XD reference actually catch up intrinsically. You are an XD, but right now you are regarded as a reference of X class. So similarly, the child object can be stored as a reference of superclass or superclass. So always remember that. So XD is object. The answer is true. B is true. XDD is X. Yes. So it's not its operator is not saying that its type is matched. No, we just follow this hierarchy, this class inheritance hierarchy. The children class is always can be regarded as the parent's reference. So remember that, it's very important. Okay, all right, but not the reversed one. So XDD, yes, it is an X class. So the answer is true. But how about the parent? Parent cannot substitute the position or role of the child class at all. So B2 is false. B3 is false. All right, so you need to know this kind of structure. So that is the S. So sometimes and we want to use cast. In C#, if we want to cast some, so for example, if we have obj, so remember that as we say, every class you defined it is intrinsically implicitly inherit from the object. So if you ask X is object, XD is object, okay, let us see the answer, okay. So X is object, answer is true. Everything is true, even though the constant is true. So if I add another one, $5.5, it's look weird, right? So let me execute to this point. All right, B7, 2. Okay, so every instance in the memory is actually can be regarded as an object. So that is why we can use the tree node. We can special our universe or fuzzy set, store that in the tag, in the control tag. Control tag as a type is, they ask it just object or just object. But intrinsically we know. Right now, XD is not just actually XD is an object of XD class, right? So we know that. So after that, so usually you can say that later on if we use it, we would like to do that instead. So you see, OBJCD B5 equal XD, right? That is the way we kind of stored it. So XD OBJCD B6 OBJCD store X. So that is the mechanism we kind of store our universe objects into the tag, right? So later on we need to cast it back. So how can you cast a type into another type? We use the type. So we say X. We kind of cast our B4. B4 is the object, right? So we cast it into X somehow. So this is the cast. We kind of use it. All right. So it's okay. Cast into X, and if XD, if we want to cast XD. XD, if we want to cast B4, then you use this way. But that will fail, right? Because B4, excuse me, B4 right now is object of X, right? It's an object of X. So in order to cast that as child class, it will fail. Alright, so it's about the time, even though we know X is an object of capital X, so right now we try to regard it as a simple object. So we execute it. So B4 is object, but if you move your cursor to here, you will see definitely the computer knows intrinsically is an object of X, capital X. Even though right now it is regarded as B4. Okay, so similar these two. So move your cursor, B4 actually know is XD. B6 is object XDD. So right now we try to cast it back, right? Right now we have object variable b4, we need to cast it back to the x. So we execute this one. So after this point, it's okay. So right now, x is actually x object. Can we cast that into the derived class? You see, you get a runtime error. So computer know that if you want to cast an object, try to cast that into a derived class, and derived class should have more data, right? But right now you just have a variable a there. It's not going to happen. So that will fail during the runtime. So we kind of use this cast technology to bring back the original type of, we like to resume it, right? So the one way is that you use this cast. So this is the expression or casting in C# programming. Another way is that you use this operator as. As is another operator in C#. The functionality is similar to the cast, but this cast will generate an exception, right? Because it will generate an exception, so your system, your application will crash. But as will not generate an exception. If it is not convertible, then it simply returns none. So let us see what will happen here. So this is the cast we have been using. Another way is that, suppose right now, similarly, we want to cast back, I may call it XXXS. We want to cast B4, right? B4, how can we cast B4 into X? B4 as X, another cast. So we cast it into back, right? Cast the object. So B4 is the object, B4 is the object, B4 is up, but we know intrinsically is an object of X, not the XD. So this will generate exception. Similarly, if you take a look, XDD, XX, XD, B4 as XD. So let us see what will happen here. So ordinary cast, okay, up to this point, system crash, your system crash. So cannot cast this back to XD, see? So intrinsically, computer know the data type of your object, even though right now it is treated as an object variable, so it's okay. So we need to comment it out, otherwise we cannot execute it. Oops. So let's try it again. Oh, I did not set breakpoint, sorry. It went to the end. Okay, so the cast is all right. And another way to cast B4 as X, it will be okay. So move your cursor to the x-axis. Right now, it is valid. Right now, we just pointed to the X object. How about this cast? B4 definitely is not XD, right? B4 is an object of X. So will it fail? Will it generate exception? No, no exception generated. But instead, your XXD will turn out to be none because it is impossible. So just pay attention to these differences between use type and parenthesis to cast it and another cast operator called as. They are a little bit different. Okay. So what were this related to our assignment? All right. So if we go back, to your project, so let us go back. Just give me another 5 minutes. I will finish that for you. So go back to our main phone, right? So usually we kind of have add fuzzy set, right? Add fuzzy set. So in your code, add fuzzy set will be very lengthy right now, right? So we will check the selection of the user, right? So user might click on here, click on a fuzzy set, Gaussian fuzzy set, Bayes fuzzy set, then we check the selection. We check the selection. If it's 0, then we Gaussian function. So we knew Gaussian fuzzy set, right? New Gaussian fuzzy set. So we prepare a local variable, right? Gaussian fuzzy set. Gaussian fuzzy set. For the triangular set, we define a local variable, triangular fuzzy set. Triangular fuzzy set, right? So in particular, we prepare the type, the reference type of particular data type right here. But if you look into the rest of the code, they are all the same, right? Tree node, add a tree node. And then this guy is different, right? This is Gaussian fuzzy set, so Gaussian fuzzy set name, triangular fuzzy set name, right? So this is the beauty, okay? Take a look at here. So what you really need is that you have a generic fuzzy set new fs. Arbitrary, you can just you simply just specify a variable, new fuzzy set, new fs. Here, you don't need to specify new fuzzy set. So you kind of instantiate an object or derived class, right? But you assign the reference to the parent, the type of the parent fuzzy set. You see here. How about tree node? Well, tree node is okay, just a new fuzzy set. So new fuzzy set. Tag equal. Oh, excuse me. Yes, new fuzzy set. New fuzzy set. Kind of GFS. So we only have one variable defined, new fuzzy set. New fuzzy set actually create you create an object of Gaussian fuzzy set, right? But your reference has been assigned to the parent variable right here, right? New fuzzy set. So new fuzzy set name same. So how about the triangular fuzzy set? Again, we don't need to do that. New fuzzy set selected. New fuzzy set. Take a close look. New fuzzy set. 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 So why we bother about the same code? So we simply, we simply move this code, this part of code, to the end of this switch statement, all right? Up to this point. Oops. Sorry, made a mistake. So I kind of cut it, move it to the end of this switch statement. So up to this point, I deal with that. So what will remain within this switch statement? That's it. I kind of create new fs. I kind of create new fs. I kind of create a new fs right here. I don't need to specify the derived class variable at all. I always just have one new fs there. So remember that if you have a family of classes, actually, even though you instantiate a derived class object, it can always be regarded as the top class reference. New fs. New fs. We're almost down there. Okay. All right, up to this point, see? So the only difference is that I have a new fuzzy set about to be created, right? But actually, if the user chooses 0, then actually I create a Gaussian. If it is 1, then I create a triangle, but I always treat it as a parent partition. So that is the beauty. Okay, what is that? You see, once I create it, then I will create a tree node, right? So new fs name. Okay, this problem came out. Okay, non-initialized local variables. Since we have a local variable, but it's okay because definitely we will instantiate. So if this came out, you simply initialize. Initially, since it's a reference type, the initialization should be equal none. So after that, there should be any warning message. So once the new partition has been created, then you see every particular partition should have a name, because we treat it as the superclass. So have name, special text, special tree node, blah blah. It's okay. So your code will turn out to be a much more neated way. But you need to know, object of the derived class can always represented by the parent's reference. We like to do the manipulation in the upper level later on, doing all kind of operation. All right, I think I have used up a lot of time, so just let us take a break right here. So later on we will go back to the virtual stuff and the operator stuff there. Okay. All right, so let us take a break, and we'll be back. 哎，是
那个我有把那个 binary 加上去了，需要再上传给你吗？
Okay, let us go back to our object-oriented technology study project. Okay, so let's go back a little bit back to our console project. So let's set it start project. So right now we know the object-derived class can be treated as the parent. That is the purpose we like to have them. So suppose, you see right now I have main function, right? So if I have a list, dynamic list, we kind of use the class in the dynamic list. This is what? X, L. So since it's an object, so we need to, so right now we have this LST, okay, LST. It's much more. We have this. So we have an X object instantiate, right? So whatever. So create it, LST add this guy, X object. We have XD instantiate, right? XD print something out in the console. Fine. We also keep it, add. Why we can add a derived object? You see, this list is a list of what? Of X object, right? Capital X object. But since the object XD is a derived object, right? So it can be regarded as an X, as the parent X. So definitely my list can accommodate, can collect, can accept this XD object. So that is the idea. We like to accumulate all the object of this X family together. Treat each one as the superclass. Okay, that is the way we kind of do it. Because object-oriented try to provide extendability, right? We don't know what kind of new derived class will be created by the user later on. We don't know that. So what we can for sure is that I will design a very complete parent class. So no matter what kind of new derived class will be inherit from my X class, I can always treat that as the object reference of the parent class. So that is the idea in object-oriented technology. So, all right, similarly, so I kind of add LST add XDD. Right? Okay. So up to this point, well, everything's fine. I may look through for each. I use kind of for each statement. For each statement, it's kind of new. I mean, if you are C++ guy or C guys, you don't have this one. So if I want to simply print out something, I can use for each what? For each x. I'm going to call it xobj. This is the local variable name, xobj in list. I will ask h1 xobj dot f. Take a look at our class structure. Well, we have f function. We do not have another f function defined in xd, right? Either in xdd, right? So if I call f, so f will be called, right? F will be called. So f actually is inherit from the capital X class, right? So xd, even though right now I'm an xd object, I still can call f function, right? Yeah, okay. So I might add another one. So probably I should add for each x object. I kind of console directly. Console write, not write line, write something first. It's very interesting. I mean, I try to write the type of this object, xobj. Okay, so I put it type here, xobj get. You see, every object of your class definitely have a function called get type, right? So get type and to name, type of name. I kind of print out the name first, and then I call xobj. So let us see what will be printed out here. So take a look at the code. I kind of create a list, right? So once the x is instantiated, I edit. So right now I have 3 objects. They are all different class, right? They are all different type, but they are belonging to the same class, X class. So I treated that as a X references. Okay, take a look at these 3 lines. So the first one, the type is capital X, right? The second one is XD. The third one is XDD. When we call f function, you see, when we call the f function, simply print out this information, x dot f. So this function is defined in the capital X class. So xf dot call a, fine. But remember that they are of different type, right? The first one is the x, second one xd, xdd. Okay, so it came out that we like to collect all the derived class object together as a list of superclass. That is the idea we operate in object-oriented style. Because later on we don't know what kind of particular derived class will be created. We are not going to deal with that type at all. We always deal with the superclass, the type. So no matter what kind of object you have created in the derived class, it is always treated as the superclass reference. That's the idea. So, but later on, probably in our family, I might provide so-called, well, the f function should be different, right? Because SD might have, for example, let me change the name. I kind of change that, the name it, right? Call it date a girl. Okay, date a girl, f date. Oh, never mind. I simply use string. Use a stick. All right, so I have a function kind of void. So what will happen? Is recurring command. Is it okay? Oh yeah, I'm debugging, so I need to terminate. So I kind of changed the name, date a girl. So similarly, the list here, date a girl, right? Fine, date a girl. So the grandfather uses stick. father uses stick, son also uses stick, but definitely no way, right? So some derived class might have its own implementation of this function. So how can we do that? So in that case, because right now every particular object has been regarded as the capital X references, right? So the only way, is once we access the date girl function, always invoke this function, right? So in this time, the object-oriented designer think about that. Well, probably the derived class will have its own implementation, but definitely every great children should have this capability, data girl, right? But they might use different kind of methodology to do that, not just inherit from the old parents. That kind of method. So in that case, if I'm a class designer, I would define that as virtual to preserve some optional for the derived class. So I kind of specialize virtual one. So up to this point, no any children overridden, right? No everybody. Fine. So everybody, the parent, the grandfather, father, and the son, they are using the same way to date a girl, use a stick. Okay? All right. So if later on you design a derived class, so for example, in the XDD, in the XD, I kind of change it, not use a stick. I would like to override it, right? So far, X has a virtual function, data girl. XD, if I want to override it, I kind of implement it by myself, override it. You see, that is the way you have been doing, and type a blank space that the Visual Studio provide. This for function has not been overwritten yet, so you can choose that. Oh, okay, I have a data girl, I can override it. I want to override it. So I override. I'm not going to use a stick. I use diamond. D-I-A. Okay, so father to override it, right? So let us see what will happen. Once the list data girl came out. All right, you can see the X is the first one X type, right? Use a stick. Father use a diamond. How about son? You see, how about son? Because son is a grandfather, father, son, right? So we have XD does not override this function, right? If a derived class does not override a function, it will use the one, or its base class. Oh. You see the differences because in our XDD class we do not override it, right? So if you have another one, you will have another STD, D. Okay, I add another derived STDD. Okay, so I kind of added that again. So right now we have 4 objects. Essentially, STD, D, D, D. I don't have a function called that. This added STDD. So right now we have 4 guys. So let's execute it to see. All right. So X uses stick. XD, because XD override it, right? XD has override this function. So the rest of the children, if the children does not have any its own overridden function, they will share the toughest label. This function. So XD use a diamond, XDD use a diamond, XDD use a diamond. How about if I override it in the XDD class? So knowing that the first one as a virtual function is declared. The XD override it. XDD does not override it. Yet XDD override it. Override it. Data girl. So I will copy this line. Okay, use an iPhone. Alright, so XDDD override, but XD does not override, alright? So now let's see what will happen. So you can see X uses stick, XD uses diamond. How about XDD? XDD does not override it, so it will use the parents method. So XDD uses diamond, but how about XDD? No, XDD is a newer generation, so you use iPod to data girl. iPhone, anyway. Alright, so that is the inheritance we like to let you know, so you can practice a little bit more about this kind of mechanism. So when you go back to the fuzzy set idea, right? Fuzzy set, we kind of design a family of classes, right? So in the genetic fuzzy set, we kind of define all the necessary functionality data right there, and we provide. We know we have foreseen that a fuzzy set will participate in certain kind of calculation, so we prepare function there. And usually you can define every function as a virtual fine, because if a function is declared as virtual, then definitely you will have extensibility for the derived class later on. I mean, if a user want to add a derived class to your class, so this kind of mechanism provide extendability or object-oriented technology. Okay, so is there any question about this demo class stuff? Demo? Even though we will go back to our assignment 4, right? I still have something new to add. Set up the startup project. So let me see what kind of functionality has been provided by this student. Okay. All right, so it's good. Create universe. Find universe. So on this universe, we set Gaussian function. Gaussian function. So I select the Gaussian function. I like to add some unary operator. How about the cut, value cut scale, right? So it's kind of unary operator. Okay, value can be specified here, but created, right? So define on the same universe. So right now I have 0 cut point 1. So once you click on this Gaussian function, definitely you will have this parameter ready for you to set it, right? So if I change it into the 2, fine. But how about the cut? If I set cut, it just have a name, right? But definitely we know, since it's a unary operator for this set, actually, okay. Let me add another cut, because this student provide the initial setting right here, right? So now negate. Suppose I select value cut. Okay, it's kind of user interface is very needed. Okay, it's kind. So I might specialize probably 0.4. So initial value is 0.4, and then I add a value cut. All right, great. So we have a cut fuzzy set, right? Generator. So it's a unary operator fuzzy set. So suppose I change the parameter or the original or the primary fuzzy set. Suppose I change the mean to -2. Everything should be changed, right? So you will propagate this kind of parameter change event. So everything will be automatically maintained. But the problem is that if users knowing that your unary operator has a parameter, right? So if I click on this guy, right? If I want to change the cut value from 0.3 into another value, how can I do that? No way. See? Right? So this is a unary operator fuzzy set. The parameter depend on the original fuzzy set and the operator. So that is why I'm asking you. You are capable of doing that by yourself. Look back to the universe. You kind of add a parameter change event there, right? So you can do the simulation by yourself. I'm not going to instruct you step by step. Otherwise, you will learn nothing. So you will need to add that parameter change event to your unary operator fuzzy set. Once you have it, you will once again click on this unary operator fuzzy set. the fuzzy set and the operator will be show up right here. Today the user change the parameter right here. You don't need to provide such kind of check bar initially for the user to create a cut. But okay, I mean so far it's working anyway. But the problem is that we kind of go back to our unary operator fuzzy set, right here, right? So we know this unary operator fuzzy depends on the generic fuzzy set and this operator, right? So we might like to publish this property to that the user can access it through the property grid. So how can we do that? So you kind of declare property public, and generic fuzzy set. Again, you see, we always treat that as the superclass. I don't care whether it is triangular or whatever. It is a generic fuzzy set anyway, no matter what kind of specific fuzzy set it is created. So we call it okay, I call it capitalize the operand. It's simple. I simply return get the operand, right? And how about the operator? Yeah, we also like to publish that so that the user can access it. Unary operator. Since this is unary operator for this set, so we call this operator. Capitalize. So carefully, I think some of you made a mistake. You cannot return itself, okay? So pay attention to this is lowercase is the operator. Excuse me. Let me copy it here. So you need to watch out. This get return lower cases. If you type a capitalize, you kind of self reference. It will generate error. Not this way. Okay. So okay. So even though we add this property, what will happen? Let us see. The universe, right? So we add a Gaussian fuzzy set. Select it. You see, this guy has a foolproof. After the selection, you need to do some logic checking and then disable or enable certain kind of pattern. So value cut, special value, and I edit. So I edit. Okay. So what we have done is that we try to add two property, right? So if I click on this unary operator fuzzy set, interesting. Identity. Nothing shown up, right? Did I compare it correctly? Let me rebuild it again. Unary operator fuzzy, yes. No. Okay, yeah, I have a bug. Okay. Oh, yeah. So remember that it's a little bit different from C#. Okay. So for each cases in C#, you need to end up with a break statement. Button click. Okay. Zero reference. So if it is zero, then it will be saved to delete it. All right. The universe under the screen is add a fuzzy set. Select this Gaussian. Select value cut. From the value setting, add it. Set. Click on it. Okay, that is the one. That is the two actual property I like to show up, right? So I might like the user modify the operator. If the operator has a parameter there, I can special it. But it is hindered right now. It's kind of just read only, right? But I can access. I cannot. You see, theoretically, if I click on this operator, since it's a Gaussian fuzzy set, it will pop out the property of this Gaussian fuzzy set, right? But it is by default not showing up. So okay, let me try that. I'll show you how to do that. So back to the unary operator for the set here in this property, the operand. Try to add some property. The property might call type converter. I can exactly remember TYP type. Yes, type converter, this attribute, it is located within the system.component model. Type converter. And then type O. Expandable object converter. We try to expand its property. I don't know whether it works or not. I cannot remember exactly. Let me quickly take a look at it. So create a universe. Add Gaussian fuzzy set. Select Gaussian fuzzy set. Add value cut. Operate. Add it. Select it. Okay. Yeah. That's right. So you see, I have two properties, right? Publish, but user cannot access it. But if I add that attribute to that property, the user can access the parameter right here. So right now, either way, you click on this Gaussian, you can set parameter. But again, I can change the parameter, the dependent, what is it, via this unary operator what is set. It's kind of weird, right? Usually we don't want to let this happen. We like the user click on this primary what is set property. But what I'm showing you is that actually we should not do that. We should let the user, because operator, there is no any operator tag shown up here, right? So but if user want to change the parameter of that operator, then definitely we need to let the extendable specify on the operator. Okay, so this is not the one we want. So actually we don't like that. But if you change it, you will see. Because you are dealing with the same guy. The object itself just one copy there, right? Either way, you through the primary fuzzy set, or otherwise through this reference refer to the same. Both of them are always referring to the same Gaussian fuzzy set. So if you change the parameter right here, the shape will be changed too. Okay, so either way can do that. But usually we are not going to let this allow the users special, but the operator, we do need to open that. So I'll kind of move this to this place and add another. So actually we don't need to open that. So we kind of comment it out. I don't need to publish this property, but definitely because the user might change, because my unary operator has parameterized, so we like to provide this kind of ability to let the user modify the parameter for it. So add a fuzzy set, click on this fuzzy set, value cut, edit. Here I click on it. So right now operate has been specialized as public property. So if I click on it, I think you did not implement the parameter yet, right? Do I have a parameter especially in this cut operate? No. All right, that's the point that I ask you to do that, because no matter it is a unary operator or binary operator, some operators do have parameters. So you need to define it by yourself. I mean, it's just similar to the fuzzy set, okay? And then define a parameter change event there. So the parameter showed up right here. For example, right now show 0.055, right? So I can change the cut value 0.5. So I can change 0.3, and then once I change it, property changes, fire the parameter change event. So you will see, well, the cut value will be changed accordingly, right? Okay, so probably it's not so important in this moment, but later on, I mean, if you are familiar with this kind of mechanism, you can add your own event to the operator. So remember, the operator do have their parameter. So for example, right now, because there is no any tag, there is no any tag, especially on the tree view, right? So the only way we can access the parameter change is via this unary operator file system property setting right here. Okay. So what I'm saying is that if we quickly take a look at the unary operate unary file system operate right here. So negate, okay, does not have any parameter special, right? Concentration no, dilation, cut here. So in cut, in the constructor, you see, we kind of, well, great. This guy do extension and parameter, yeah, dimension is 1, parameter 0. Why you need to time alpha? It's just, okay, probably that's related to your interface. But usually we can special initial value will be okay. For example, 0.5. All right, 0.5. So it's about the time we populate this property, public double cut value, right? It's meaningful name. I mean, in the property cut value. So user can either specify. So we have get. Simply return our parameters 0, right? And we needed to set up guarding condition. If value great equal 0 and value small equal 1.0, right? We allow this change. So parameter value 0 equal value. Okay, so add this property. But I'm still asking you, add an event. Okay, add a parameter change event to your unary operate. To that, this mechanism automatic generator. Well, probably, well, I will do that. So let us go back to the top of this class, unary operator right here, unary operate. So since we have parameter, right? So similarly, we will declare we have public event. This time, we just take a range of existing event handler. It's a dedicated event handler. It's a dedicated. It's defined in Dynamic framework. Last time I showed you how can you define your own dedicated. Okay, okay. So I call it again. That is parameter change, right? And unfortunately, they are just parameters. So we will use this name parameter change. Okay, you need to fire it. So parameter change event, right? All right. So public predict. So let us go back to our cut value. So cut value, right? Cut value right here. So cut value right here. So if value satisfies the requirement, so since you have changed your parameters, so we will check parameter change. We fired it. I don't know whether can we do that or not. Otherwise, we need to prepare a function. And since he required 2 arguments, so this, no, maybe not. Okay, does not work, right? So parameter change needed to see. Okay, so we need to prepare a function in the base class. Okay, right here. So we prepare a protected shell, protected void. change. Well, I may call it file. Parameter change event to let you clearly understand what this function is for. Okay. So how can we file it? We just check whether it is empty or not. If it is empty, nobody subscribe it. If parameter change none equal none, then we file it. Use this. We do not provide any argument for it. So we have a shared inherited function ready for you for the rest of the derived class to fire this parameter change event. So up to this point, since we have value change, right, parameter, so we file it, call it fire parameter change event. All right, so in here, again, so you can do similar thing in binary operator, all right? So it should be your responsibility if your operator has parameter specified. So we kind of add again, this time add a parameter change event. Also provide a function for the derived class to directly call it to fire this event. Okay, so it's not completed yet, but so far you can test it. So we add a Gaussian file set. We have car value operator to have a parameter associated with it. So we add it. If we use a click on it, all right. So operate. There is a place to let you change the value, right? So car value, right? Car value 0.5. User right now can change it to 0.8. Fire, right? Fire. That's fire. Even have fire, but what about this resulting? But it does not change, right? That is because we did not subscribe the parameter change event, right? So let's go back to the unary operator for this set. So remember that this is a unary operator for this set. The constructor is right here, unary operator set. So operator specified, created a fuzzy specified. Then we will create a unary operator for this, right? So remember that in here we subscribe. Both of them has parameter, right? Fuzzy has their parameter. And because you depend on both of them, so you need to subscribe parameter change event or these two guys once they have this kind of event. So right now we add our unary operator fuzzy as event. So here you should operate dot. See, you got a Thunderbolt there. It's an event, right? Parameter change. So parameter change event plus equal and hit tab key. Do you need to change anything? Because you see, you have subscribed the fuzzy set parameter change event right here, right here. Fuzzy set parameter change event. So you don't need to specify a new one. You simply just specify this function name will be okay. You don't need it because even though you let it, okay, if you let the Visual Studio prepare a function skeleton for you, double tap twice, Visual Studio prepare this function. But again, the function is still the same. You need to fire this parameter change event. You don't need to do that. Both functions, the logic are the same, so you don't need to do that. So you simply copy here. Both parameter change. Whoops. Excuse me. Which one left? Operate for this parameter for this one. Okay, I need to do this one. Oh, excuse me. It's not allowable, right? Because this event change, we cannot define our own delegate, right? You see, I get the point, right? Because last time I showed you how to define your own delegate in order to fire an event. So you see, the function does not take any argument, right? Does not take any argument, right? So I'm sorry, we needed to let the Visual Studio prepare this function for us because we have different kind of delegate, So plus equal, hit tab key twice or just once. You see, the function, the signature, we so-called the signature of the function is different. because delegate is different. Okay, the delegate we have been using is the default event handler delegate. This one is delegate is defined by us. Okay, does not matter. Doesn't matter. We need to have different kind of function, but implement the same logic. So we call this function. We call this function change. Okay, this is the way, because two event does not have same delegate. So you need let the Visual Studio prepare this function skeleton for you to do that. All right, so remember that right now we kind of add a Gaussian function set. We have unity outputs. Which is again. Okay, never mind. Car value do have parameter associated with that operator, so we create it. So right now, user has the capability to change the property, right? So user will not going to change the parameter or the fuzzy set, because assuming the Gaussian fuzzy set, the changes should be the responsibility of this primary fuzzy. So if a user changes 5, you can see our unity fuzzy set has shipped. But how about the parameter, right? So click on this guy. We will change the parameter via this operator, 0.5. So it's about the time change into 0.8, enter. Right, bingo. That is the way we modify the parameter or the operator. So you need to prepare event. So always think about that. If you design a class, if later on some other guy, some other class might depend on you, and take a look at it yourself. If there is any important data, probably the dependent one will rely on it. You should design an event today the user can subscribe it. Okay, that is the one I'm talking about. So I think it's probably it's very complete. I mean, the functionality of unity operator is complete up to this moment. So you should implement that by yourself. But remember that the one I just showed you, the derived class object can be always treated as the reference of the top class. That is the way we are using the object-oriented technology to help us do the complicated job. Okay. So I think that will be all for assignment 4. Is there any other particular problem? All right. Okay, if you do not have anyone, we should step into assignment 5. And probably we are not going to complete the instruction for assignment 5 in this class. So probably I will shoot another video, maybe within 1 hour will be enough for assignment 5 instruction. So before we step into assignment 5, is there any question about your current work? Okay, just all right. So if you don't have any question, we take a look at the assignment 5. What kind of So in assignment 5, we needed to extend our functionality to let the user specify fuzzy if-then rules. So take a look at the demo application. What kind of user interface we needed to learn to use it. So should I? Let me take a look at this user interface. Okay, seems alright. What I was using here is this one is called tab control, and Type control is another container type control. So, okay, let me show you. So let me add another form. Add Windows form. Does not matter. I mean, you can feel free to add and then delete it. So it does not bother your application at all. So what I have been using, remember that always use split container to split container. Yes, split container. By default, it will duck its parent space, right? So if you add a so-called tab control, this is tab control. So take a look at its property. Look into its property. It's always pay attention to a collection stuff. Tab pages collection, right? So we do have so we can easily add or remove any one of them. So each page will be another container, can host other control. So this is the tab control. And if you have probably you have button, label. You can always use a container, for example, group box. The group, oops, group box. You can use a group box to group them together. So right now, these two are the children class. So you can disable the group box. So all the content data item will be disabled, and then enable it. It's much easier for you to do the logic or hide or show the control for the user. All right. So in assignment 5, the first things we need to do is that we add another label or this tribute. So we will let the user select whether he wants to add an input universe or an output universe. So, but remember that user can specify a universe on input file more than one, right? So once the user take a look at here, if then rule is on this page. So once the user add a input universe, one column is a table, one column is added. Add another universe, second one added. Third one, user click on the output universe, add another universe. That should be output universe. So within this control called data grid view. Data grid, I will show you a little bit about how to use it. So we have a header. Each column will have a header. So what actually done when user add a universe is that we add a column. We add a column to this so-called data grid view. We add a column at it, but not a condition. Condition user should select or specify the condition, right? So condition on the universe, there might be in this user interface. I kind of collect all the variable files into a list box. So it's kind of advanced method. I'm not going to show you how to do that, but I will instruct you use a print data grid view to just similar to these two guidelines, because each label will have a tag, right? So similarly, each cell or a data grid view will have a tag. We can store that in the tag. So later on, we can construct an if-then rules through this from this data grid view there. So user click universe, then here, if user add a file, take a look at here. If user and then I cannot add a rule, right? So you see, right now I cannot add a rule, right? It's kind of for at least every fuzzy set every universe should have a fuzzy set defined. Only in that case, this button will be enabled. How about 3? Left shoulder. Not yet, right? Output universe should be specified. Output as function fuzzy set. All right. So up to this point, the user has specified the fuzzy set on each universe, right? So take a look at this rule. Oh, okay. Right now it's ready for you, for the user to add a rule. So add a rule, just add a row to here. So I can add a rule right here. And then I have prepared, because up to this point I know there is a var1 variable in f1, x1. Oh, I have var1. So this is the only way he can do, right? He can choose. So by this quick, user can specify this rule. If x1 is var1, and x2 is Gaussian one, and x3 is the left shoulder one, then output x4 is SS1. So this is kind of what if then rule. So later I will show you, probably we just use print cell. So use a similar way. Well, so if we click on this cell, then we select the fuzzy set, then this fuzzy set will be stored in the tag of this data review cell. Right. So that is why that is the purpose we want to set up. And data user might specify condition, right? Condition. So user might add a condition right here. So the condition might be I don't know, add one. So this one will serve as condition, another condition, another condition. So user needs to specify the condition in order to inference the fuzzy set, right? So up to this point, I just have one rule. So user right now is about to select condition. So the condition is var1, right? Excuse me, the rule antecedent is var1. So right now condition is Gaussian 2. X2 is Gaussian 3. So up to this point, once user has specified the rule, I can inference this condition. So I can inference this condition. So the result will be generated on our output universe, right? So it's cut value. So we use cut. If the user deselect, this is not okay scale. So right now scale. Sorry, because they are operated, so you cannot see it. Yeah. Okay. What if user change, right? User change the Gaussian standard deviation, change it into 5. Condition has been changed, right? So it kind of it's irrelevant, okay, because first change does not change at all. But later on we will practice that. So in assignment 5, what we need to provide user interfaces that we might need some space to keep this data review and also conditional data review and prepare some data to let the user add a rule. So rule is there, and we have inference button ready for the user to click on it. So let me see the instruction. So enhance, right? Again, enhance your 04205. So last time I showed you how to do that, right? Just make a full copy and then change the solution file and change the folder name. So you need to do that by yourself. And up to this moment, you need to check that we have added a parameter change event to universe, to fuzzy set, to the operated fuzzy set, right? So up to this point, so wait. Oh, okay. In the assignment 4, I would like to introduce you. Well, probably I will talk this in this class before we end this class. Yeah, we don't have time. I think we don't have time to talk about the data review. I will shoot another video for you, right? But before we leave, I will let you know how to do that. So up to this point, this student has added a unity operator fuzzy set, right? So we know we have cut fuzzy set operated, right? Specified, and then we can generate a unity operator fuzzy set. So we like to define. We like to override the operator. So this time, see, cutting operation, we like to have our code expression like this one, 03 minus fuzzy set variable. and then yield unary operator for this set. So we will define this minus, and since this minus is a binary operator, even though we are creating a unary operator for this set, but your operation involves two operands, right? The first operand is 0.3, 0.3. Actually, it's a parameter, and then another one is for this set. Okay, so how can we do that, and how can we use it? All right, so go back to our genetic for this set. I think we need to go back to our genetic for this set. Where is it? Right here. Genetic for this set. So we kind of define public, static. It must be static, and then create an operate. It's keyword. Must be keyword. We try to redefine, we try to override, we try to overload. Oops. Minus operate. And since minus operator take two operand, right? So the first one we might is a double. I call it cut value. The second one should be, if you want to override an operator, at least one parameter should be the same class right here. So that is why you define within this class operand. Okay, this is the keyword. You cannot change it. You need to use operand, right? So what will be returned by this function? Unary operated for this set. So we try to define this minus. So minus involved a cut value and an operand for this operand, and we'll return a unary operator for that. So start from the beginning. We prepare i.e. SURT, right? Initial, and then we return it. i.e. SURT. That's it. So this is a function skeleton operator, right? This error came out. Let me see. Oh, public and okay. Once you have this kind of problem, is that because right now my function is public, right? But probably some other guy, this guy might be not public, so this error will be checking for that. So genetic for this set, unary operator for this set. So I need to go back to the definition. Go to definition. Okay. By default, if you do not specify the accessibility, it's internal. That means only the class within this project can use it. So since I right now declare as public, so I declare as public. So let's go back to our generic quality set. Yeah, the recurrent disappear. Okay, so how can you define operate? So operate right now, So unary operator for this set, right? Result, we kind of new unary result equal new unary operator for this set, right? Unary operator for this set. Require an operate, right? Unary operate and for this set. So the for this set is okay, operand, right? That is the operand. We can direct separate it. How about the unary operator? So right now, you see unary for this set operate op equal new, not the genetic one, right? New cut. I don't know the name. Yeah, this is the class name defined by this student. Cut for this set operate. So I create an object derived class, right? But always regarded as the superclass. as a unity, general unity for this operate. So yeah, I need an alpha value, right? I need a variable. See, the constructor asked me that I need to specify the parameter value. Oh, it's okay. It's okay. Just my cut value. Get it. So I have OP instantiate, and then work on this operand. So I return this OP. That's it. Operate minus like that. So how can we use it? How can we use it? So right now we have operator overloaded right now for our fuzzy set, our generic fuzzy set. So how can we use it? So let's go back to our main form. So when we create unity operator fuzzy set, right? In this case, that should be cut operator, right? Yeah, right here. Cut. So we kind of knew a cut operator, right? So we generate a cut fuzzy set. Why do we have this one? We will change that, right? Oh, okay, okay. I didn't change that, right? Yeah, similarly, right? Unity operation. I do change this guy, right? The fuzzy set. So right now our code is simplified, right? And but for this one, unity operator for this set. All right, so see, you see, you can simplify this code. I mean, later on is be the similar skeleton. But right now here, I like to use that operator. So cut operator right here. So the requirements that we create a generic for this new. Well, that's okay. New operator for the set. Right here. So we have a cut. We need to create a cut. So okay, right here. So our cut for this set is equal what? Equal this value. Pick up from the user interface, right? Minus the guy you have chosen for this set operator for this set. So this kind of expression is what we like. You put the real numbers minus the fuzzy set, then we get a actually what you get is a unit of the fuzzy set. But unit fuzzy set is a direct class object, right? So it can be assigned to the parent, right? So that is the override one. So let us see what will happen. Let us set a breakpoint. Value cut. Add1. So we are about to execute this line, right? We're about to, so right now we have user special values. This, wow, 45. Why? Okay. I think he has certain scale. Well, that is the reason because it came from what? Come from this track bar. So actually you can set the maximum value. Oh, okay, I understand why. Because that must be integer, start from 0 up to 100. All right, so I got it. So it's simple. We just come back here. Time, it's okay. Keep using time. 0.01, right? Okay, that's it. See, we have expression. Have it. All right, and Gaussian. Click on Gaussian, select cut value. So up to this point, use the track value 31 times 0, so 0.31. And for this set is ready. So we enter that function. We hit F11 key to debug it. Oops, not working, huh? Genetic fuzzy set. So we set the breakpoint right here. So make sure it do stop right here. Universe, Gaussian fuzzy set, Gaussian fuzzy set. Select, value, edit. So we are about to execute. If I hit F11 key, you see we came to here, The value, you just time it, move your curve. Cut value right now 0.57, operate. So the similar code happened right here, right? So what we need to do is that we knew that we instantiate an operator first. Oh, I hit F11 key, so it's about to create an operator. And then we use that new unary operator fuzzy set. That should be result. And it always treats us the upper class, right? So result. So the result should be the same. But in the U expression, you kind of use this operator, minus. All right, so that is so-called operator overloaded. So in the instruction saying that, well, try to do that. I mean, later on you will see, probably later on you will have what? You will have this kind of expression. Well, I have genetic fuzzy set result equal A, fuzzy set A plus fuzzy set B, something like that, minus 0.3. Such kind of expression will be much more, I mean, it's easier for us to catch it, okay? So that is the beauty of operator overloaded, okay? All right, so because during the fuzzy rule inferences, what we need to do is that, well, we need to use the condition antecedent and try to get the intersection, right? So if we put intersection A and B or B like that, so such kind of expression will be helpful for us to understand the operation during the inferences. Okay, so the first thing is that you make sure event to implement, and then you have overload operator. So A and B, so I mean A intersect with B, not A negate operation, right? So A or B, 0.3 times A means scale, 0.3 minus A means operator. So you can choose any arbitrary symbol or the operator to override it for you, right? So in this, let's say to virtual property. Oh, okay, we need to add one, so at least we can finish that. It will be easier. So right now, because during the fuzzy inference, we needed to know the maximum degree, maximum value of fuzzy set, right? So we will add it's pretty weird, virtual property, right? So let us go back to our genetic fuzzy set. So it's about the time we extend the capability of our fuzzy set. But usually we need to enhance it right in the toughest class, I mean the generic class. So here, that should be related to the property. So probably, right, we add a property. It's property, double. I don't think the name is maximum degree, right? So max degree. So we like to have a property available for us. During the fuzzy inference, we need to refer that. So maximum degree get. By default, it's 10, right? By default, it's 10. Because all the primary fuzzy set, we have call, right? We have call. So at least one point should receive the memory degree 1.0. So generally it's okay. But if it is the normality does not hold, in that case we need to step by step calculate the maximum value, right? So for the rest of for some fuzzy set, it is not equal 1, right? It's not equal. So in that case, the property cannot be set figure. So in this case, we would declare that in general, for a genetic fuzzy set, the maximum degree is 10. That is true, I mean, for general. But for those fuzzy set whose massive degree is not equal to 0, they need to override it. So in this case, but in fact, you know, even though it's look like the property look like a data, right? But in fact, it is it consists of a getter and a setter function, right? So since they are functions, so they can be declared as virtual. Today, the derived class override it. So here we will declare that as virtual property. VIR, TUA, add a virtual keyword there. So who needed to override it? Unity operator file set, right? Unity operator file set. Binary operator file set needed to override it because the normality may not be hold, all right? So, but since the unity operator file set needed and unity operator file set needed, so probably here we will provide a protected function to share. Protected function to share between the derived class. So we call it a double GAL character max degree. So how can you calculate maximum degree? The logic should be really simple, right? Maximum ND initially set to what? Double minimum value. Return ND. Let me change it. MX max. Alright, how can you do that? Well, you need to traverse from the universe minima up to universe maxima, right? You try to call your give membership degree, right? So the logic is simple, but who needed to call it in order to override the maxima degree? Definitely this guy. Unity operator fuzzy set. Unity operator fuzzy set. Usually, if it is cut, right? If it has been cut by a value, right? The maxima degree will not receive 1.0 at all. So in unity operator file set, you need that is your responsibility. If you create a derived class, inherit from the parent class, then you need to override. So here I need to override it. Use this keyword type of blank space. Intelligence will show up. Those virtual function has not been overwritten by your class. So right now, you see not just virtual function, also virtual property, right? So maximum degree right here. So you need to override it. So maximum degree equal what? Not the base one. You will call calculate maximum degree. Override it. Override it. Because the normality usually is not whole in the derived in the operator fuzzy set, right? So you need to call it. So let's go back to, and how about similarly, if you define the binary operator fuzzy set, you should override the maximum degree in order to get a correct value, right? So let's go back to this function. Oops, not this one. Highlight it. Click on this side. Move to the definition. So here, what can you do? For double x start from where? The universe, right? Minimum value. Similar to the series point populational function there. Actually, you can do that. You see. Delta or increment, right? Can't remember the name exactly. So I have typo here. DOUBLE double DOUBLE. So we have membership degree equal what? Get membership degree, right? X. So we kind of look through each point. Record what you need to report is the maximum value, right? So if maximum value, if MD greater than maximum value, then maximum value equal MD. Oh, that's it. So at the end, oops, excuse me, X equal MD. Alright, so initially we set it to the minimum value and we will get it. So this function is very easy. But you need to check each fuzzy set. Sure, that fuzzy set needed to override this mathematical degree. So the one I just showed you is that unary operator needed to override it because its value is not exactly equal 1.0. Okay, this is the first requirement we needed to use it because in inferencing a rule, we needed to have this property ready for us to use it. So basically, we have a condition, we have antecedent, and we get the intersection of these two fuzzy sets, and then this fuzzy set will report its mathematical degree for us to find that rule, right? So this one is important for us. Okay, so we add a class for fuzzy if-then rule. Probably use this name. Investigate the data structure required for a rule, right? For example, the antecedent part is a list of fuzzy sets on different universe. So make sure they are on different universe, right? And the conclusion part is a fuzzy set on upper universe. All right, so in assignment 5, I just put in here, okay, you needed to copy your assignment 4 once you complete it and then into assignment 5. So here I quickly add a class. If then rule. If then fuzzy rule. So by default it's internal, right? So if all your class has been declared as public, and later outside we can use it. So what kind of data structure required? Antecedent, right? So a rule will contain antecedent, right? What is the antecedent data type? Should be a list. We kind of use dynamic array. Actually, you still can use fixed array, okay? But dynamic array will be much easier for us to interact with the user. So user can easily delete one antecedent and add another antecedent. It's okay. So list of what? Generic fuzzy set. Antecedents, right? So since it's an object or list, so usually in definition you can initialize it. Antecedent. And we only have a generic fuzzy set. Alpha fuzzy set, right? Or we might call it conclusion. All right, it's a rule, right? But not just data. If you design a class, in addition to the data, you should have certain kind of member function dealing with those data. Okay, so if I have this data, I might provide a public function, inference. The rule. I'm a rule, right? But if you ask me to inference my rule, you need to give me the condition, right? So the condition, again, you can provide different kind of parameter type. But right now, conditions, condition, maybe okay. So this function will take the condition, right, and inference our rule, and finally return back what? A generic fuzzy set again. We know definitely eventually probably if I just have a rule, right? What we return just one unity of the fuzzy set, probably a scale, right? But doesn't matter. We always treated that as generic fuzzy set. So that is the inference procedure. So within the function, we can prepare generic fuzzy set result. Initialize, return it. So we kind of design using the object-oriented technology, you need to think everything always in terms of class and objects. And a class should contain data and the function dealing with those data together. So wrap it up. So later, this if-then fuzzy rule will provide a service. We can invoke the inference the rule, then we will get a fuzzy set back. So how can you do that? You need to do it by yourself. So look into the slide. Actually, what you need to do is that, well, antecedent, the number of antecedent, number of fuzzies should be exactly the same as the condition, right? So you use the antecedent 0, intersect with the condition 0, right? Intersect. So you use a binary operator, generate a binary operator, right? And then once you generate the intersection, you need to find the maximum degree. So finally you get the first antecedent filing strengths. But antecedent might involve more than one universe, right? So you get the first filing strength, second filing strength, third filing strength, and then compare those values. Determine the final strength. Final strength should be the minimum value. Use that minimum to cut what? To cut your conclusion fuzzy set to return that back to the user, right? Look into the slide, and then you can blindly implement your code right here. Remember that antecedent, you can pick it up, numbers. Numbers O S. How can you get an antecedent? Well, you can pick an antecedent.count. So if it is a list, a dynamic array, it always provides a count property for you to let you know how many items has been stored within this list. And if it is so-called fixed array, how can we specify fixed array? This is fixed array. So you need to specify, well, right now I have 5. So this is a fixed array. So since SS is a fixed array, so it always provides a length for you to know the number of items stored within this list. Okay, so remember that. But so far, in our if-then rule, we like to use the dynamic array to store the antecedents, probably at S, and around there. So antecedent. So you know the antecedent. So actually, what you need to do is that you need to do some checking. So the number, the count of the antecedent should be the same as the condition, right? Condition, we need to check the dimension should be the same. And also check the fuzzy set. The fuzzy set should be defined on different universe, right? The antecedent parts or condition part. So you need to double check that in order to inference a reasonable output fuzzy set to the user. So now is the if-then rule class we need to create. Probably later on you will populate it with some other data and the function there. Yeah, okay. So we have okay. The function name is called fuzzy in, fuzzy out inference. Okay, fine. So let me change the function name to make it meaningful, not just inference the rule. Fuzzy in, fuzzy out inference. So that means it's a fuzzy list, fuzzy set list, and we get a fuzzy set output. All right. So we have function there. For pull mechanism should be for that, another should be different. Okay, so you need to check that when user drag and drop a universe on your data review. So I will prepare a video showing you how to use the data review to host the rule. Okay, later on. I mean, that will be probably available tomorrow later on. Okay, so the user interface to create rule. So we need to special button and data review. So I will show you how to use that in a later video. So in particular, upgrade your tree view. Okay, so tree view we need to upgrade it. So let me do it right here. Condition. All right. So let's take a look at this tree view. So you need to hard-code it the first label right now. I mean for assignment 5. Okay, give me another 5 minutes. We will end it up right here. So that should be the nodes, right? So the category is node. A tree view is a control. The property it holds a node, it's a collection. So we add two root node. The first node, we are calling it what name? Text. That should be text property. Text, yeah. Input. UNIVERSES. Input universe. Output. Just one over universe. So by default, we have a new label came out. So you need to check the. So later on, you should upgrade the logic right here when the tree view the selected node has been changed. You need to change the logic here. But here you see, we know user might select different kind of different tree nodes. So if you access the tree view TRV fuzzy model, selected node is the attribute, right? Once you get a selected node, if you want to access, there's a tag, right? We kind of secretly hide our object there, right? So again, since it's a node, it can always has its children. Node is children. We have face text, right? And here you need to know there is a property called label. Okay. So the label is with respect to the hierarchical structure or the tree view. So in the first label it should be 0, label 0. That means it's a parent. It's a parent node. So once we add it, you need to check the label, and also there is a property called what? Index or what? Let me check. Do I have an index or not? Yeah, you have an index. Index, that means within the same group, within the same sibling, the index you press. So you need to check. Sometimes you need to refer to this property in order to identify whether the selected node is located. So you need to know the label. Sometimes you need to know the sequence among the sibling. So you will check about the index. So check that. See the explanation. So in order to knowing what tree node has been exactly selected to, in order to hide or disable or enable some control, you need to carefully check that property too. All right. Okay. So up to this point, I think that will be all for today. I kind of use up a little more time. Is there any question or any problem up to this point? So you need to rearrange your screen, right? So anyway, just take a look at the demo application. You can follow that layout or structure. At least there is a sample there, so you can get familiar with how to get a good layout for the application. That layout is not the best one anyway. You can still have your own layout design. That's fine, but make sure it's foolproof. So don't let the user confused or frustrated. Using your application. Okay. Well, that will be all for today. So if you still have any question, just feel free to email me, or just catch me, all right, in your office. All right. So that's it.